Our discussion today is on calorimetry. Calorimetry, as the word should represent, is calor for heat and metry for measure. In other words, the measurement of heat. Specifically in chemistry, we're going to talk about the transfer of heat. The measurement of heat is done by studying the transfer from hot objects to cold objects, which is how heat goes, from an excess of heat to a deficit of heat. The way calorimetry is done is by studying a reaction in a beaker. Let's say you have a beaker. You have a reaction going on. Let's say it's an aqueous solution. This reaction generates heat. That heat is absorbed by the surrounding water. So we really can't measure the reaction. If you have A plus B gives C, the reaction is at the atomic or molecular scale, and it's too small for us to measure the amount of heat that these atoms give out. But we can measure the water which is in bulk. So we can put a thermometer in the water and measure the heat. But actually what we're measuring is the temperature. We can measure the temperature before and after. That way we get what is known as delta T. Delta T is the change in temperature. Why are we measuring the change in temperature? The reason we're measuring the change in temperature is because the ruling equation of calorimetry is delta H equals mc delta T. You might have seen this reaction referred to as the MCAT reaction, and it's just called MCAT because it looks like MCAT. Alright, now in the MCAT reaction we have three variables, mc and delta T. M is the mass of the substance that we're measuring. In the previous case it is water in grams. C is what is known as the specific heat capacity. And delta T is the change in temperature. Now the change in temperature can either be measured in degrees Celsius or in Kelvin, and it does not matter. It is exactly the same value. These two numbers for a change in temperature are equivalent. The specific heat capacity is measured in joule per Kelvin per mole. And I actually made a mistake when I wrote this. It's only measured in joule per Kelvin per mole when the formula is NC delta T. Which means that if specific heat capacity is measured in this unit, you need to use moles right here. What I should have said was that specific heat capacity is measured in joules per gram per degree Celsius. So we're not doing moles, we're doing grams per degree Celsius. Again, it doesn't matter if it's degrees Celsius or Kelvin. It could also be joules per gram per Kelvin. Okay, so that's the story of the MCAT equation. What does the MCAT equation give you again? It gives you delta H, sometimes known as Q. Either way, it is the change in heat. It is the heat lost or the heat gained in a certain process. A little bit more detail about how we actually measure this heat lost or gained. Okay, an instrument used to measure calorimetry is a calorimeter. Surprise. Now calorimeters can be very basic, and the most basic form is called a coffee cup calorimeter. I'm just going to change my color for some variety here. So let me draw what is my best approximation of a coffee cup. It is important that this coffee cup have a lid, and it is also important that there be something in the coffee cup. So typically this is water. Remember that water is the medium in which most reactions happen. So you have some substance reacting with some other substance in water. Okay? Let's say you have hydrochloric acid reacting with sodium hydroxide in water. This reaction is a known exothermic reaction. If you remember the meaning of this term, it means that it generates or releases heat. Okay? So what is going to become hot? Heat is released by the reaction. Where can it release heat? It can release heat to the surrounding water, right? So this heat is going, while my arrow one goes above the water, what I really mean to say is that this heat is going into the water, and the water is becoming hot. How on earth are you going to measure the water becoming hot? With the help of my thermometer right here. So I know the mass of my water, check. I know the specific heat capacity of my water, check. I know the change in temperature because I have used my thermometer to measure the initial and the final temperature, check. mc delta T gives you the heat gained by the water in this exothermic reaction. Because there is nobody else around, the heat gained by the water must be the heat lost by our HCl NaOH reaction. And thus we have found the heat of reaction of hydrochloric acid and sodium hydroxide. Does that make sense? Now the one thing that is less than sophisticated about our coffee cup calorimeter, that became too tall, but regardless, is that it's a coffee cup. It's made of styrofoam. We use a coffee cup because styrofoam, excuse me, let me fix my screen for a second. Okay, I made a marginally better version of my coffee cup right here. So the reason we use a coffee cup is that I said this coffee cup is made up of a material called styrofoam, and styrofoam is somewhat insulating. But it isn't going to be terribly insulating. What does it mean that it's insulating? It means that it's not going to exchange heat with its surroundings. Why is it important that it not exchange heat with its surroundings? Because we're trying to measure the heat that the reaction generated and gave to water. And if the reaction was giving heat to everybody else around, then we wouldn't really know how much of the heat water got and how much was released to the surroundings. So, this is an approximate measure at best. If you want to go to more sophisticated measurements, you would use what is known, scarily, as a bomb calorimeter. Okay? A bomb calorimeter is used for really sophisticated measurements, and it has a small, usually metal container called the bomb. This is where the reaction happens. Now this reaction can be any reaction. Often combustion reactions, which is things catching fire, are done here. Okay, this is my approximation of a combustion. So if you're trying to see how much heat does methane generate when combusted, or how much energy does sugar give you, you would burn this in here. And the heat generated by sugar in the bomb is now transferred to waters hopefully surrounding this container. Okay, that should have been blue, but regardless, you understand what I mean. Okay, you're going to do the same thing with the water. There's going to be a thermometer sitting in the water. You're going to do your MC delta T, mass times specific heat times delta T, and that gives you the heat gained by water, which is going to be equal to the heat lost. The only advantage of this measurement is that it is much more accurate. This was a much longer talk than I'd hoped to give. However, I want to stop this by something that we haven't covered completely in here. I want to know that for all heat measurement questions or heat transfer questions, the ruling equation is not MC delta T, but the heat lost is equal to heat gained. Okay? There's another way of writing this if you include the signs of heat. Heat lost plus heat gained equal to 0. The reason in this case I haven't accounted for the signs of heat lost and gained being different, and in this case I have accounted for that. So the sum of these will be 0. Okay. No matter what kind, you might get a bunch of different kinds of questions. Sometimes you have these questions where you have a container. We're going to go with water again, but somebody dropped a hot, I don't know, maybe a potato in here. Okay. And they're going to say, okay, sorry for that. And they're going to say, what is the new temperature of the water? Let's say you knew the temperature of the potato to start with. So we're going to do M potato, C potato. The potato is losing heat, right? So we're going to do M potato, C potato, delta T potato, which is the final temperature of the potato minus the initial temperature, let's say it was at 100 degrees Celsius, plus the heat gained by the water, M water, C water, the final temperature of the water minus, now we're going to say maybe it's 20 degrees Celsius. The water was at 20 before. The sum of these is 0. At this point of time, hopefully, you have the mass of the potato. Somebody has given you the specific heat of the potato. You do not know this guy. You have the mass of the water, you have the specific heat of the water, and you do not know this guy. So it's just a linear equation in one variable. Remember, one of the more important things is that the potato and the water are going to attain the same final temperature. If two objects are touching each other, once the equilibrium is attained, they're going to be at the same temperature, eventually, okay, given time. That's going to be at the end of this really long recording. Thanks for listening.